In this lecture, I will talk about amplitude. Each signal has an amplitude. For example, we learned sinusoidal signals that are in the form of V of t is VA cosine of omega t plus c. The amplitude of this is sinusoidal signal is VA. So each signal has amplitude. But amplitude itself has different definitions. We have different types of amplitude. So in general, we have four different definitions for amplitude. The first type of amplitude we will discuss is peak to peak value. Peak to peak value. Okay, peak to peak value, which we show with V sub PP is equal to V max minus V min. This one is a definition of peak value. Before showing the peak value in an example, let's see the second type of the peak. The second type of amplitude is peak value. Peak value. Peak value, which we show with V sub P, is the maximum of absolute value of V max and V min. So we have absolute value of V max and absolute value of V min. Whichever is which one is bigger, we consider it as V peak. Let's show them in two different signals. Here we have a signal, an square shape signal, which is in this form. Okay, it's a periodic signal. And the maximum value of the signal is here V max. The minimum is here V min. Okay, so V peak to peak is the difference between V max and V min. So from V max to V min, we call it V peak to peak. V peak, we look to absolute value of V min and V max. So it's V min and here is V max. Which one is greater? We consider it as V peak. Here in this example, the absolute value of V min is greater than V max. So we can say that this value, this amplitude is V peak. Let's see another signal. We have a sinusoidal signal, and the signal is shifted in amplitude upward. And of course, it has a maximum value and it has a minimum value. V peak is the maximum. They're like V peak is from this point, which is V max to the 0. So here is V peak. Okay, and V peak to peak is the difference between V max and V min. So V max and V min is V peak to peak. Okay, so here is the first two types of amplitude that we learned. The third amplitude is average value. Average value. The average value can be determined by this equation. V average, VAVG, is 1 over T. T is the period of a signal. Integral of T for one period of the signal, Vx dx. So we calculate the integral of the signal for one period and then divide it by T, and the result is V average. So let's see V average in a signal. Here we have a signal. Okay. The maximum value of this signal is VA. The minimum, of course, is negative VA. And one period of the signal is T. We want to find V average of this signal. Okay, so let's use the equation of V average to find the average value for this signal. V average is equal to 1 over T integral of 0 to T VA sine of 2 pi T over T dt. Why I say sine of T, not cosine of T? The answer is in the graph. If we look to this graph, we see that the signal starts from the 0, so we can say it's sine. Of course, we can say this signal is cosine of omega t minus 90 degrees, because we know that the cosine and sine are exactly same signals with 90-degree phase shift. Okay, so now we want to find the integral of this the signal. We know that the integral of sine is negative cosine. Okay, of course, integral of sine of AT is equal to negative 1 over A cosine of AT. So let's apply this to our equation. We will have 1 over T minus 1 over A. Here, A is 2 pi over T. Cosine of 2 pi T over T for range of 0 to T. We can write it in this way, is equal to minus, oh, I missed the VA here. Oh, of course, we need to have a VA here, VA over, because the amplitude of the signal is VA. So VA, capital A, V minus VA over 2 pi over T. So it is negative VA T over T 2 pi cosine of 2 pi T over T for 0 to T. These T's are cancel each other. They cancel each other, and we will have minus VA over 2P cosine of 2 pi minus cosine of 0. Cosine of 2 pi is 1, cosine of 0 is 1, so V average is equal to negative VA over 2 pi times 1 minus 1, which is 0. So the average of a sinusoidal signal, complex signal, no like a shifting amplitude or um, half a signal. I'm talking about the complex signal. A sinusoidal signal always has an average of 0. The next signal we want to find the average value is the signal. Okay, so we have this signal. The maximum value is VA and the period is T. Please note that this signal was a sinusoidal signal, but we cut the negative part of the signal and remove it and just consider the positive part of the signal. So we want to find the average of the positive part of the signal. Let's do that. So we can say V average is equal to 1 over T integral of, for one period, which is from 0 to T. But from 0 to T, we have two different like regions. In one region, we have signal. In one region, we have nothing. Okay, so we need to like consider the part of the time which we have the signal. So from 0 to T, uh, for half of the period, we have the signal. So instead of considering calculating the integral for one period, we calculate the integral for half of the period. So because the other half of the period has no signal. So from 0 to pi over 2, VA sine of 2 pi T over T dt. It's equal to negative VA over 2 pi cosine of 2 pi T over T from 0 to T over 2. If we calculate this term, the answer is VA over pi. So V average for this signal is VA over pi. Okay. The fourth type of signal values and peaks is called root mean square. Root mean square. VRMS, which is like the most important peak in between these four types. In fact, VRMS is a measure of the average power carried by the signal. So it tells us the average power that this signal generates. Okay, so VRMS is a measure of the average power carried by the signal. Okay, Vrms is equal to square root of 1 over t integral of v of t square d of t. Okay, so this one is the Vrms equation. Let's see these 4 types of signals in an example. Example, find VP, V peak to peak, V average, and V RMS. Here is the signal. Here is 2VA, and here is minus VA, and the signal starts from 2VA, goes to minus VA, then it returns to 0, goes to 2VA for 1 second, and again returns to 0. Okay, we want to it has, let's continue the signal because we want to find the period of, we need to find the period of the signal. So at 6, the signal again goes to -1 and goes. Okay, so what is the period of this signal? If we look to the signal, we see that from time equal to 0 to time equal to 4, we have the signal, and after that, the signal is repeating. Okay, so t is equal to 4 seconds. Okay, t is equal to 4. Now, what is the V peak to peak? V peak to peak is the maximum of absolute value of 2VA and absolute value of VA, which is definitely 2VA. V peak I'm sorry, it's the V peak is maximum, V peak is maximum of value between 2VA and VA. V peak to peak is V max minus V min, which is equal to V max is 2VA, V min is minus VA, so 2VA minus VA is 3VA. So this one is V peak to peak. Okay, we know that period is equal to 4, and the average can be calculated using this equation, 1 over t integral of v integral of v of t to dt. Okay, which is equal to 1 over 4 integral 0 to 4 vt d of t. But if we look to the signal from 0 to 4, it doesn't have like a unique or same equation for one period. From 0 to 1, we have one signal. From 1 to 2, there is no signal. From 2 to 3, there we have another signal. And from 3 to 4, there is no signal. For those parts that there is no signal, we don't need to write any integral because integral will be 0. But for those parts that include signal, we need to like separate them and separate the integral for each of those parts. So we need to write two integrals, one integral from 0 to 1 for this part of the signal, and another integral from 2 to 3 for this part of the signal. Of course, for the regions 1 to 2 and 3 to 4, we don't need to write any integral as the signal value is equal to 0. Okay, so let's just split this integral to two integrals. So we say 1/4 of the first integral is from 0 to 1. The value of the signal at this region is 2VA d of t plus the other part of the signal is other part of the integral is the integral from 2 to 3. The value of the signal is negative VA dt. We need to find this integral. So it's equal to 1/4 of, okay, integral of 2VA dt, of course, is 2VA t. So we will have 2VA t from 0 to 1. For the next one, minus VA t from 2 to 3, which is equal to 1/4 of 2VA minus 0 minus 3VA minus 2VA, which is equal to 1/4 of 2VA minus VA equal to VA over 4. So the V average for this signal is 1/4 of VA. Now let's calculate Vrms. Vrms is equal to square root of 1 over t integral of vt square dt is equal to 1 square root of 1/4 of 0 to 4 v of t square dt, which is equal to square root of 1/4 times, again, the same as what we did for V average. We need to consider those parts of the signal which has the signal. So this part and this part. So we split the integral for one period. We split it to two integrals, one from 0 to 1 and the other one from 2 to 3. Okay, let's do that. uh, integral 0 to 1. The value of the signal for 0 to 1 is 2v, because it's a square of 2v, it will be 4va squared. So 4va squared dt plus the second region or second integral is integral from 2 to 3. The signal value is negative va. The square of negative va is va squared dt. It's equal to the square root of 1/4 of 4va squared t from 0 to 1 plus va squared t from 2 to 3, which is equal to 1/4 of 4va squared plus 3va squared minus 2va squared, which is equal to 1/4 of 4va squared plus va squared equal to the square root of 5/4 of va squared is equal to the square root of 5 over 2 va. So this one is the RMS. Okay, the next example, we want to find the RMS and the average for this signal example. We have the same sinusoidal signal which has only positive parts, pi, 2 pi, 3 pi, and amplitude is 1. And the equation of this curve is sine of t. So v of t is sine of t. We want to find the equation. So v of t is equal to sine of t. Omega t is equal to t, because the general form of signal is sine of omega t. Okay, so omega t is equal to t. As a result, omega is 1. 2 pi over period is 1. So period is 2 pi. It is exactly what we're showing here. 1 period of the signal is 2 pi. Okay, now we continue after finding a period which is 2 pi, which we needed. We start calculating the average. The average is equal to 1 over t integral of sine of t dt, which is equal to 1 over 2 pi integral from 0 to 2 pi, 0 to 2 pi, sine of t dt. 0 to 2 pi is one period. If we look to the signal, we see that from 0 to 2 pi, it's like divided to two regions. In the one region, one in the second half, there is no signal. So instead of calculating the integral from 0 to 2 pi, we only need to calculate the integral from 0 to pi, which we have the signal, okay? So we change the integral limit from 0 to 2 pi. We change it to 0 to pi sine of t dt. It's equal to negative 1 over 2 pi cosine of t for the range of 0 to pi, which is equal to negative 1 over 2 pi cosine of pi minus cosine of 0. Cosine of pi is negative 1. Cosine of pi is 0, and cosine of 0 is 1. So the inside the bracket we will have negative 1. So we can say the average is equal to cosine of pi is negative 1. Sorry, cosine of pi is negative 1, and cosine of 0 is 1. So negative 1, negative 1 minus 1 is negative 2. So the average is minus 1 over 2 pi minus 1, which is minus 2, which is equal to 1 over pi. So this one is the average. Now it's time to calculate the RMS for this signal. The RMS is square root of 1 over t sine of t square dt, which is equal to square root of 1 over 2 pi integral 0 to pi, because from pi to 2 pi there is no signal, integral of sine of t square of okay, let's just write it here, sine of t square dt, okay, and it's equal to square root of 1 over 2 pi, integral of 0 to pi, the integral of the sine of 2t, or not sine of 2t, sine of t square is equal to 1 minus cosine of 2t over 2 d of t, okay? So we need to like do this conversion to be able to calculate the integral. It's equal to square root of 1 over 2 pi. We split this integral to two integrals. Integral of 0 to pi 1/2 of dt plus the integral of 0 to pi of negative 1/2 of cosine of 2t d of t. Okay, now it's equal to the square root of 1 over 2 pi. The integral of 1/2 is 1/2 of t, so it will be equal to 1/2 of t from 0 to pi minus 1/4 of sine of 2t from 0 to pi, because we know that the integral of cosine of at is 1 over a sine of at. I applied this rule to this integral, and here is the result. It's equal to square root of 1 over 2 pi. It's pi over 2 minus 0 minus the sine of pi is equal to 0, sine of 0 is equal to 0, so 0 minus 0, it is equal to the square root of 1 over 2 pi times pi over 2. Pi are cancelled, so it's equal to square root of 1/4, which is equal to 1 over 2. So here is the result. We found the Vrms of this signal, which was equal to 1 over pi, and V average, sorry, which is equal to 1 over pi, and also we got the Vrms, which is equal to 1 over 2. Okay, it's for today's lecture. See you in the next lecture.